would you agree that the process of evolution happens at the DNA level?
Um, so I think probably mostly, but that there is so there's what's also called like Evo Devo, developmental evolution, and but developmental evolution is the idea that changes like in the way the embryo develops are uh, have a I don't know why I can't talk. So like changes that go on during the development of the embryo have big effects on the characteristics that the organism has. And so obviously development is guided by genes, but there's also I mean there so the genes themselves don't have to really change. It can just be like the rate or the timing at which the genes are expressed, but then there can be like subtle environmental things that have a big influence too. So organisms can evolve without their DNA really changing that much. So I usually say it's changes in genes and gene expression.
Okay. So you're saying changes in gene expression, but once it's copied to the next generation, how does are you saying those gene expressions hold?
What do you mean by hold?
Are they copied over because they're copied on the DNA level?
Yeah, but they may be expressed differently.
They will.
There are for example there are well we have like recessive
I would say.
alleles, right?
I
They're
would
in your
say they
genome but
will.
they're not expressed. They may show up. This is a classic example of something that kind of sort of skips a generation in a way.
When you say they may be expressed differently, why do you say may?
Well, because the environment has massive impacts on gene expression. So, for example, in the Netherlands, there was a horrendous famine Germany World War II. And what they found was women that were pregnant during that time, there were not mutations in their DNA, but changes in the DNA molecule structure that made their children many times more likely to be obese because it sort of reprogrammed them in a way so that their bodies retained calories more than the typical person.
Because when you say they changed those structures, what is passed on is just the genetics. It's just the DNA. So
Yeah, I
how
mean,
would
you
that
only
be retained?
inherit. Well, because the methylation it's called methylation because that happens to the mother's DNA during her lifetime. It's actually a very
So it is
Lamarckian
a DNA
thing.
change.
Well, it's a change in the structure of the DNA, which can cause the genes to be expressed in different ways. So the genes don't have to mutate, but they can become so like for example if you take identical twins and you separate them at birth, we know for a fact that all of their genes are the same. But if you separate them at
Yeah.
birth and they grow up in like one of them grows up in a environment where they're extremely malnourished and the other does not, they will literally they will be very different even though their genes are the same because one of them because the environment can change gene expression.
Yeah, I'm still just trying to figure out where because you're saying the gene expression will change, but then what will happen to their offspring?
To their offspring?
Yeah, the different
Possibly nothing at
expressions.
all. Because the
Yeah, that's why I
only
was asking why you said.
what did I say may change?
Yeah, you said the gene expression may change.
Yeah. So like whatever happens to me during my lifetime, I can only pass on changes in my DNA that happen in sperm cells, you know? So like
Yes.
if I grow up extremely malnourished, that may not actually have a large effect on the DNA within my
Offspring.
gametes, right? But it might,
Yeah.
and we know that that happens because of, for example, the Netherlands thing.
The Netherlands thing. So so you're saying that there wasn't a change in their DNA, and is this a study?
Yeah, yeah, this has been studied extensively. We know for a fact that stress and famine and other things causes sections of your DNA to open and close, different sections to open and different sections to close, because not all of our genes are active at any one time. So we know because of the extremely heightened risk of like obesity for their children that there were like changes. We call them like the DNA gets methylated. There's another word for the opposite of that. I can't remember what it is, but that's what causes those types of things to be inherited.
Is it inherited, or are they just left with the same?
No,
Um,
it's
are they left
it's
in the
inherited.
same environment, which is the famine?
No, because after the war, those people were not growing up during a famine, so they weren't even overeating. They were eating as much as a person. They were highly susceptible to obesity because their bodies retained calories more than other people. They had a lower basal metabolic rate, probably, and other things. I'm not a doctor, so I probably shouldn't say too much about that, but.
Yeah, I guess I would have to see the study to actually see what you're saying, because for me it's not very. I'm trying to see. You're saying there will be some changes above the level of DNA, but then also
It still
passed
changes
on.
to the DNA, but the DNA isn't
Yes,
mutating.
this is what I'm trying to get. Yeah, I'm trying to make sure I understand what you're saying. If you're are you talking about the level of DNA or above?
Well, it's epigenetics, so it's above the level of DNA.
Okay, and
Yeah,
the
I mean
genetic
we've known
level.
about epigenetics for a really long time. There's other things like temperature
Is that the
for
thing of DNA turning on and off
it's what it does is so like
based
gene
on
expression is
environments?
extremely complicated. It's a symphony of genes interacting together. Like what determines how tall people are? There's no such thing as a gene for that. There's a single gene that makes our hair the color it is, but there isn't a gene for how tall humans are. It's a symphony of a bunch of genes working together. So environmental factors can influence that. It's called epigenetics. So, like for example, for crocodiles, well, this is the case for lots of reptiles. Their
Yeah.
sex is determined by temperature. So I can't. It's like opposite in
Temperature at
turtles
what
than it is in
stage?
crocodiles. I don't remember. The cold ones either turn into boys, and then the
Sorry,
warm ones
sorry,
in
sorry.
girls.
Oh, sorry, you said temperature at what stage?
Well, when they're still eggs, so
Okay,
like
so
the
still
embryonic
developing.
stage. Yeah,
Okay, so while they're developing. Okay.
yeah. But what it does is it changes the gene expression.
Yeah. Okay, that makes sense. But that gene expression is not going to be inherited. A
No, in that
specific
case, that
gene
is not.
expression.
That is definitely not something that's inherited. But
Yeah.
in this other case, like with the, I'm just going to keep referring to the same thing, the Netherlands study. Uh, that is a case where, like, it's kind of weird. It's not a gene, but you can inherit it because it's part of the gene structure, I guess.
Do you have an analogy for that?
Um,
Because if
I,
it's not a gene and
I
it's the genes that are copied, how can it be inherited directly?
well, because it's a structural change to the DNA. So
So then it is oh, okay. Maybe I'm
to
missing
inherit just
something.
means that it's passed down from parent to offspring, and so they're
Yeah.
passing on their DNA, but the DNA has been altered in
Okay.
these ways. So like it's kind of just potato
When you're
potato.
saying structural change, you don't mean order. do you?
No, it's the methylation just it's
You
basically
mean,
like imagine you have a book with a billion pages and
yeah.
some of the pages are always glued shut so you can't access them. This is just a case where different pages are glued shut and some that were glued shut are opened. And that's the difference.
Okay, and those can be inherited.
I would say that inherited is an okay word to use here, yeah, because it happens to the parent and then they pass on that DNA, yeah.
So, inherited, you shouldn't use that word, or you should.
No, I said I said I think you can. It's kind of a weird way to
Okay.
use it, but I think it's fine.
Do you know what? If you're thinking it's a weird way, then there's probably something I'm missing.
Well, it's just we only think of inheriting genes themselves, but a big part of the function of the gene is whether or not it even will be expressed because of these structural elements of our DNA. But because that's
Okay.
something that changes in the parent, I say yeah, it's inherited if it happens to affect sperm or egg cells.
Okay, and then so those, I'm guessing that of course is going to be mixed with the male and female DNA, and that will make it different as well.
Yeah, I mean it might only have to be one of them, I guess. That I don't know off the top of my head.
Okay, yeah. Okay, let's just to move on. I was thinking, um, what do you consider evolution is on the DNA stage?
Well, any change in allele frequencies can be considered evolution, but I mean, to evolve just means to change over time. I mean, it's not even remotely arguable that organisms evolve. So, but what are the implications for that? Do species actually change over time? Well, yeah, I think we have
No, I'm
enormous
talking about
amounts of.
just. I'm sorry if I'm cutting you off. Let me know actually, because I don't know if I'm talking about specifically in the DNA stage. What is evolution like in that stage?
What is DNA like in the evolutionary state?
I mean, how does, because evolution is I don't want to put words into your mouth. It's mutations, right,
Well, going back
of the
to
DNA.
going back, it might not be mutations. It can be changes in gene expression too, and a
Yeah,
lot of that can come from the like developmental biology side.
but for example, like do we have like a do we know the extent of changes that gene expression can cause? What
Well,
types of
yeah, I mean
changes?
there are some we know. I mean there are all kinds of
Are they
like genetic diseases we
physiological?
know that we know what their cause is. Yeah, but I
Would there
mean
be any?
there's way more we don't know because of how unthinkably complicated uh, gene expression in organisms is.
Would there be anything like body structure changes caused by
In
gene
terms of
expression?
DNA, yeah, they're called Hox genes.
No, I'm saying the changes in expression. Would are there any examples of changes in expression that that are on the like by the body structure level?
Yeah, Hox genes. So these are
And what
genes
does that
that
come
guide the
with?
development of like body parts, especially limbs. And we know that the timing of those Hox genes greatly affects the structure of like the limbs and the body segments. And for many organisms, especially like segmented organisms, they don't have they don't have multiple copies of some genes for part of their body. The genes are just active during their embryonic development for longer, leading to multiple segments.
So are you saying things like extra limbs,
Uh, possibly, for
or are
like
you changing the actual
crustaceans.
structure? Sorry, yeah, sorry, carry
No,
on.
like extra. Well, it's a modification of a structure.
Okay, I see. Okay, okay, yeah, that makes sense. And so the organization of the DNA will be more essential to the body structure changes, right?
Could you say that again?
The organization of the DNA, like the in the order it is,
Is what?
will be more essential to the changes of body structure rather than gene expression.
No, because this is what I'm talking about is really just all about timing. It's not the order. I don't know what you mean by order, like the order in which the genes are active or
A
inactive, or if you mean the order in which the genes appear
a
on the chromosome, which weirdly that
Yeah,
actually does matter because the location of genes that correspond to the development of body parts matches the top to bottom
order.
sequence on the chromosome. It's one of these. It's a very
Yeah,
weird thing. But if you just Google Hox genes, you'll see exactly what I'm talking about. It's kind of hard to explain.
yeah. You said the order on the chromosomes. Would you say that has a bigger impact on the body structure of an animal, on an organism?
For not for evolution, I would say
No, 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 not
the
evolution, just the body structure.
yeah,
Is that?
basically, uh, it's I don't know if it's the main reason, but yeah, like literally the location of the gene on the chromosome uh, sort of determines where it'll be on the body actually in a weird way.
Yeah. Okay, so yeah, so in that situation, how does evolution work in terms of the order? Are they the same order? Some things are wrong in the replication process.
So what typically happens with stuff like this is a gene can get duplicated. We know that.
Yeah.
And then later, one of the extra copies of the gene can mutate to the point where it has now a different function than it did before, or it guides the development of a structure that is different than like the original structure, right? So
Yeah.
I think that kind of answers your question.
I think you did actually. Yeah. So essentially, that would be an error, isn't it?
Yeah, technically. I mean,
Because it's
if
a
it's
copying
if
error.
it's different, we can call that an error, and we know that that
It's not
happens
just different,
literally
is it?
every.
Remember, it's not just different. It's a copying error. So it's definitely an error.
Well, that would be an error. I mean, any
Yeah, that's what I
difference
said.
is, yeah. I
No,
mean,
not
they're not different is kind of what I'm getting at.
they're not different. Sorry,
There's no really meaningful difference between a change and an error in this case.
I think there is because if the purpose is replication and it doesn't happen exactly, that's an error.
Yeah, but it also matters like what do we mean? Well, is it an error in the sense
Copying.
that it's harmful to the organism? Well, it's not necessarily harmful, so that's not an error. Is it an error in that it inaccurately copied the DNA? Yes.
Yeah.
So,
Yeah, that's what I mean. Just but by definition, it will be an error, wouldn't it?
yeah.
Okay. So when we those errors, is that what causes the evolution?
That's a big part of it, but also the differences in development too. So it can just be changes
Okay,
in
yeah.
gene expression too.
Okay. The reason why I wanted to stay on in this like a DNA level is because when it comes to things like that, you can actually kind of like model it because you have like, for example, a, let's say a book that has a base text like the World Encyclopedia or something, and and this book, once in a while, every time we copy it, we have an error at a rate that we choose. Are you following that?
Yeah.
Okay, yeah, I just wanted to know if you understood what I said. Yeah, in when you have those errors, what essentially is more likely to happen is that the
It's
book
going to
will
just
be
turn into random
unintelligible.
nonsense, right?
Yeah, yeah.
Yeah,
So
so the
how does evolution get out of this situation?
because there's natural selection. So there's a selection process. Now, funny enough, what you're talking about literally happens because languages change. Every single generation, the way the words within a particular language are spoken change very, very subtly. Some changes stick around, others don't. And over time, a full blown different language will evolve from one language, or something we consider the same language becomes almost unrecognizably different. Like if you read 13th century English, it like you can't make out a single word, right? And so languages change like that. There are little idiosyncratic things that happen, but language doesn't turn into nonsense because there's a selection element to that. Now with like the mutations and living things, there's always like, let's say you have a population and they reproduce like mad, and so now there's huge numbers of members of the next generation in the same population. They're going to be different, but the changes that so like if you have nonsense, if you change genetic information to the point where it doesn't really say anything, then that organism's never even going to be born. The egg won't
Exactly.
even
Yeah.
be the egg won't even be fertilized, or if the egg is fertilized, it terminates almost immediately, right? So
Correct.
stuff like that, or perhaps the person is infertile, right? So there's that. But then also like the changes, not every change is equally good. So because of the selective pressure, the it's not just the case that every single change just gets into the environment and random changes accumulate. No, only selected changes accumulate.
So what are these selective forces?
It's to competition, intra-specific competition, inter-specific competition, the way that certain members of one sex choose mates. I'm gonna do this from an animal bias because
Yeah,
animals
but
are
that's
interesting.
at the higher level. That's a higher level, way higher level than we're talking about.
Wait, what are we talking about?
We're talking about the DNA level.
Yeah,
So
but
you
but
said
we're talking about
when I talked when I
if we're
talked
gonna talk
about the
about
copy.
selection, we have to talk about the organism.
Yeah, yeah. So when we're talking about copying errors, I was talking about. You said, and we mentioned that the encyclopedia will go to basically gibberish. You
Yeah,
said
but you
there'll
don't
be
have a
select.
selective. There's no selective process there.
Yeah, that's what I'm saying. What would if so? How does that work? If there's no selective process on that level, then it's just copying errors.
Right. So, I mean, I'm pretty sure I was answering that. The changes that really do result in like some sort like a severe degree of non-functioning DNA, most of those uh, even attempts of life are probably going to spontaneously abort, right? Or the egg is just it can't even be fertilized, or once it is fertilized, nothing happens, right? So there's that. The changes that do allow for, I don't know what we're going to call this, compliance or something like that.
That's
The organism
that's
can grow up, but if it's, I mean, I kind of already said this. There's going to be variation in the entire population, but the random genetic changes don't accumulate. The selected ones do. And what does the selecting is the way the
Oh, I
organism
see. Yeah,
interacts with its environment.
yeah. Oh, yeah. Talking about- When you're talking about these changes, you're talking about the selective bring is basically like new information coming into the process. Is that what you mean?
A mutation?
No, when you're talking, you said the selection. The way it will work in the DNA level is a new animal brings its DNA, which is working already, which hasn't got a series of defects. Is that what you mean?
I don't think so, but I don't really know. I didn't really follow that.
Yeah, because you said the animal would just basically die if it was left to so just those copying errors mounting over.
If those copying errors resulted in like actual like a total like entropy of or just like non-functioning DNA, then yeah, I mean it's never even going to be born in the first place.
Yeah, yeah. So what I'm saying is that those copying errors will is I don't know how else to explain it because I'm saying you're saying those copying errors will destroy the organism.
Yeah,
That's what I'm
if
saying.
they were that bad, yeah. But the
Yeah,
reason that
and
that doesn't happen is because copying errors that aren't beneficial to the survival of the organism are not selected nearly as often as ones that are beneficial.
yeah, it feels like that's just pushing it back though,
Pushing what back?
because you're talking about selected. You mean like I don't want to. How do I say this? Wait, you're talking about replication by. All right.
It doesn't have to be. This would work
Yeah.
for literally
That would be
anything.
the selecting part, wouldn't it be?
What, females choosing mates?
Yeah.
No, natural selection. I mean, that can be part of it. It's called sexual selection. But no, the fact that organisms have to try to ward off parasites and predators, or they have to try to be camouflaged or fast so that they can be good predators, or just a particular type of hardiness towards the environment that they live in, or a different kind of like small changes in metabolism. I mean, there's uncountable different things.
Yeah, yeah, yeah. Uncountable things in for like survival in the what's it near stage in terms of like the the right now situation of the organism. But I'm trying to see how the selection affects the DNA.
You're trying to see how
The
selection
selection you're
alters the
talking about,
DNA.
how it affects the DNA.
So the DNA is already different before selection happens.
So if it's already different for selection, what what use does it have to for evolution then?
Sorry, say that again.
If you say first of all you said the selection is what is stopping the randomness from
From
continuing
accumulating. Yeah. The
accumulating,
DNA
yes.
changes before selection happens.
Yes. What is those changes that happened before?
Just
Yeah.
mutations and changes in gene expression and
Yeah.
stuff like
Those
that.
those mutations are just more copying errors.
Yeah.
Yeah, which leads us to the same problem.
No, it doesn't. Because you take all of the copying errors that happen. Some of those errors have beneficial survival implications. Those are the ones that are selected. The ones that cause the organism to have all of its skin be inside out when it's born, those are not selected for. Those organisms die. before they can reproduce.
Yeah, but we're talking about the changes that happen in the DNA. Let's say you said those ones are selected um, to survive. You say beneficial mutations. That's something I probably would disagree with because I even think I understand
You
what
don't
you
think
mean
there
by
are
beneficial.
beneficial mutations?
I understand what you mean, like it benefited the person that mutated, but not necessarily in the sense of in the organism's DNA because it just lost information in order to get that mutation.
No. You
Yeah,
don't
that's
lose
what this is.
information when a mutation happens.
Well, yes, just like a book loses information when it has copying errors.
Not necessarily. If
Yes,
I
it does. I
say,
think this.
if the
I think
sentence
this is the most
says
necessary thing possible.
no, if a
Yeah,
sentence says he went to the store and we just put an S in front of it, now it just says she went to the store. That's still a
and what?
sentence.
And then
It's still a
another level
sentence and
off.
it still has a meaning. We've changed the
And then
meaning, but we didn't lose information. We just changed the information.
yeah, but then another generation after we did another one and keep going. We
Yes,
change
languages
another letter,
evolve, and they are
change
still.
another letter,
Look,
and then the word.
this language analogy is really not a good case for the idea of this. Sounds like genetic entropy, which has been debunked so
Yeah,
badly
how
by
it's not.
me, actually. But languages change exactly like what you're talking about. But
No, they don't.
not every single change is favored or selected, and the way that languages change is very random, and yet people are still able to communicate. Different languages change to the point where they are no longer the original language, but that isn't
Yeah,
losing information. It's just transforming it into different information.
yeah, I understand what you're saying. Languages change because people change what the words, the meaning of words change, not because the words have been scrambled up. You understand?
Yes, and
Yeah. So that's the reason.
For the Brazilianth time, not all genetic changes are selected for. Only ones that are beneficial to the survival of the organism are selected.
You say the ones are beneficial,
Yes.
and the ones are beneficial are what?
What do you mean are what?
Copying errors.
It 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 can be an error. It can be an error in the sense that it's not the exact same copy of the DNA, but
Exactly.
it still has a function. It can still have a good function. So in that case, it's you can call it an error, but it's not
Yeah.
valid.
A lot of the errors weapons.
How do you not understand that there is a selective process that does not select for errors that are not beneficial? How do you not get this?
You're saying it's those beneficial. You're saying beneficial in the sense that it works for the organism while
This
it's
is
alive.
experimentally proven. It's been
Do you even
experimentally
know?
proven
Did you even hear what I
so
said?
many times before. I
Did you
can
even
give
hear
you
what I said?
multiple scientific papers on this. Do you want to hear some?
Did you hear what I said? Just trying to figure
No,
out.
no,
Okay.
because your claim, I can give you
What claim
hard
was I made?
scientific evidence that completely does away with your claim. Would you like to
Okay.
know of some of it?
Could can you just repeat to me what you think this claim I'm making is?
I I don't know what you claimed, but I'm
Oh, I
talking
see.
about what you were. I'm speaking to what you're talking about with this genetic
What?
entropy thing, which is just a dumb
I thought I
idea,
was
and
way
we have
more specific than that.
scientific evidence to prove that natural selection uh, acts directly against this concept of genetic entropy.
I think I was more specific than that, don't you think?
Not really. You,
Really? Oh, okay.
no, because you
Yeah.
say
Okay.
these
All right.
long
Don't
you
worry.
say these long things, but at the end you just go,
Long?
well, It's accumulating errors. No, it's not doing that. I mean, you could say it is, but it's only accumulating
You're saying
some genetic changes.
those genetic changes are errors, as we established before. You see?
And is an error okay? I'm pretty sure actually we can fix this with one question. Do you
Okay, yeah.
actually think that every single mutation is harmful?
Every single mutation is harmful in the sense that it's an error.
No, 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 no. I didn't ask you if a mutation means that the DNA is different. Even an idiot understands that. I asked you, do you
It
think
does
that
no,
every
no.
single mutation is harmful?
I didn't say that's the distinction is not the DNA is different.
Yeah, so the question is, do you think that every single mutation is harmful? That is the
Yes.
crux of your entire argument. Did you just say yes?
Yes, because every
So
mutation
does
is
it
a harm
so
is an error.
okay, then you don't know what you're talking about because this has been experimentally proven not to be the case.
So define harmful. This
Decreases
is
fitness. That is the when if we're talking about life and evolution, that is the only metric.
that's
Decreases
your
fitness.
metric.
And fitness is measured by well, mine's not subjective, unlike whatever
You
you're
just
gonna
said
say.
fitness. Fitness is on a higher level than the DNA.
That's completely irrelevant because
Yes, it. No, it's not.
yes, it is because the
No, it
fitness
isn't.
is a measure of the reproductive capacity of the organism, and the reproductive capacity of the organism is going to determine to what degree those genes are passed down. So it's actually the only thing that matters.
No, because the
You are, oh
reproductive
God, you don't know what you're
ability.
talking about.
Yeah, I don't think you even know what the question is.
I don't think you don't even know what any of these things we're talking about are.
Yeah, yeah. That's a
Why do
Kirk.
you say that all mutations are harmful, even though we know for a
I told you why.
fact that
Do you know what?
mutations cause beneficial changes in organisms? For example, you can
Oh,
look up spontaneous mutations in diploid
oh my god.
Saccharomyces cerevisiae. This is in the National Library of Medicine, if you want to look that up.
Oh my goodness.
Okay, so why are all mutations harmful?
So you didn't hear why?
Why are they? Because it's a error in the DNA copying.
Yes.
Yeah. So that doesn't mean it's harmful in any way
Yes,
whatsoever.
it does.
How?
Because pile up the errors you have.
Once again, you have
Well,
absolutely no idea what you're talking about because you think genetic entropy is a thing because you're somehow
this,
pretending that natural selection doesn't exist.
no, no. I'm just showing that you don't actually know what you're talking about
No, I definitely
because you're
don't. You
talking.
don't.
I'm talking about. I talk about things. I like to keep things in the category we're talking about, which is that's why I try to stick with
What does
DNA
it
and that
mean
level.
What does it mean for something to be harmful?
Harmful in sense of DNA and mutations.
Sure.
Yeah, and mutation is a copying error.
No, what does it mean to be harmful?
Well, the destruction.
So if the so is that what mutations do? Do
Is that
mutations
does that
destroy
word doesn't
DNA?
have
They
meaning?
don't destroy DNA. Okay, so you still don't have an argument here. So
So the
what
word
does it
doesn't have a
mean to
meaning?
be harmful?
Destruction.
That's not an argument. What does it mean to be
Did
harmful?
I say it was an argument? What? Where are we going with this?
So you and I
You,
are having a conversation where we don't agree. We are having an
wait,
argument.
you just asked me for definition and you said that's not an argument. Come on, please.
What does it
If
mean
I'm
to be
giving you a
harmful?
definition, I'm not giving you an argument. If I'm giving you a definition, it can't be an argument. Do you
What
understand
does it
that, at
mean
least?
for something to be harmful?
I just told you, destruction.
Okay, so you say that mutations
Just
are
try and work with
harmful,
what I'm
and if
saying.
okay, shut up, Josh. You're saying that mutations are
Oh,
harmful, and your definition of being harmful is that it causes destruction. So give me one example of, or tell me how all mutations destroy DNA then. That's your argument.
destroyed it by changing the DNA. It causes failure of the organism eventually,
So it doesn't bother you
randomly
that we know
changing.
that this is like literally scientifically proven to not be the case?
Well, that's not true, but you can go
No,
ahead and explain why.
literally is, it literally is true.
Yeah, yeah, just get to the explanation part. Yeah.
That's what I'm waiting for you to do.
Well, I just explained my part.
Okay.
I'm saying you
So
said,
I actually already did. So
yeah,
DNA, the genes, that genetic information has to be passed on, right? If
yes,
changes in the DNA cause the
yes.
organism to reproduce at an accelerated rate, the genes are being passed on more successfully. That is how fitness is measured. So it's a known fact that changes in the DNA do increase fitness. So your entire argument is completely false.
My argument? What argument? Why are you talking? You're talking
Josh,
about
you're
fitness
either
and they're saying
stupid
my
or a
argument.
troll, but I think
I
you're
think,
actually both. Goodbye.
yeah, I think you.